Hi class, this is the first video for Unit 2 Analyzing Data. I am not going to make a video for the first page of the notes. That's really just an introduction to why we are doing this unit. I'm going to go ahead and get right into it as far as the videos go. So we're looking at section 2 and we're talking about scientific notation. Scientific notation is used when we're writing very large numbers and very small numbers. And by very small numbers, we are talking about numbers between 0 and 1. We're not talking about negative numbers, we're just talking about things that are very small. And everything here is based on powers of 10. So the number 10 is 10 to the first power. It is not 10 to the 0 power. 10 to the 0 power would be 1. Anything raised to the 0 power is 1. So the number 10 is 10 to the first power. 100, what we have is 10 times 10, or 10 to the second power. 1,000, that's 10 times 10 times 10. This is 10 to the third power. Up here we have 1,000,000, that is 10 to the sixth power. Here we have 1,000,000,000, 10 to the ninth power. Those are all big numbers. Big numbers in today's lecture is really anything greater than 1 could be considered a big number. And then we have very small numbers, like 0.1. In math, we would call this 1/10, or you could say it's 1 over 10 to the first power. When you have a number with an exponent that's on the bottom of a fraction, you can rewrite it. This would be 10 to the negative first. 0.01. This number is 1/100th, or 1 over 10 to the second power, or 10 to the negative second power. 0.001, that's 1/1000th. We're talking about 10 to the negative third power. 0.000001, this is 10 to the negative 2, 3, 4, 5, 6, negative sixth power. So we're looking at scientific notation, and this is about the simplest that I've ever seen scientific notation described. Most of you already have a knowledge of scientific notation, so this video should be a review just to make sure that we're nice and fresh for the chemistry school year. Step 1, move the decimal point of the number until you have a number that is between 1 and 10. Step 2, multiply that number by a power of 10. The value of the exponent is going to be the number of places that we move the decimal. The sign of the exponent is going to be positive if we move the decimal to the left, which means that we had a big number, something greater than 1. The sign of the exponent is negative if you move the decimal to the right, which means that you have a small number, something between 0 and 1. So we're going to practice these. We're going to do some examples based on the steps that we just talked about. In class, I only did a couple of the examples. In this video, I'll go ahead and do all of them. The first one, the number 23,000. So my number between 1 and 10 is 2.3. I move the decimal place from here to here. Multiply it by 10, and the exponent is the number of places I move the decimal. Now I have a big number, it's greater than 1, so my exponent is going to be positive. And I'm moving the decimal place to the left, 1, 2, 3, 4. So I get 2.3 times 10 to the fourth power. In the next one, 540,000. My number between 1 and 10 is 5.4. Multiply it by 10. The exponent is the number of places we move the decimal. So we have a large number. I am moving the decimal to the left, and I move it left 5 places. That is to the fifth power. It's positive. 5.4 times 10 to the fifth. 10,470,000. First, my number between 1 and 10, 1.047. Times 10, and I am moving the decimal place left, so it's positive, 367. 1.04 times 10 to the seventh power. 650,000. 6.5 is my number between 1 and 10. Multiply it by 10, and I am moving the decimal place left 5 places, which means my exponent is positive 5. 4,300,000. Here's my number between 1 and 10. Times 10, I'm moving the decimal place to the left, which means positive, and that's 6 places. 4.3 times 10 to the sixth power. Those are all what we would consider large numbers. They're all at least greater than 1. They all have positive exponents. So let's shift gears here. I have 0.0000033. This is a very small number. It's between 0 and 1. It's very close to 0. My number between 1 and 10 is 3.3. Multiply it by 10. The exponent is going to be negative because I'm moving the decimal place to the right. I have a small number, so I'm going to move it to the right. 1, 2, 3, 4, 5, 6. Negative 6. 3.3 times 10 to the negative sixth power. 0.00028. My number between 1 and 10 is 2.8. Times 10. I'm moving the decimal place to the right, so it's going to be negative. And it's 1, 2, 3, 4 places. 2.8 times 10 to the negative fourth power. This one, my number between 1 and 10 is 8.9. Times 10, we're going to move the decimal to the right. It's a very small number, so the exponent is negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8.9 times 10 to the negative 10th power. I included these two because you'll frequently see these in science textbooks and articles where they tell you something like 7 trillion, and they make trillion in words. So there are 2 ways you could go about this one. The first thing you could do is put it in standard notation. So here's 7,000, million, billion, trillion. And then you could put it in scientific notation. So 7 times 10, we're moving the decimal to the left 12 places. That's a possibility. The other possibility is if you just happen to know that trillion is times 10 to the 12th, we could have saved all of this and just wrote 7 times 10 to the 12th. In this next example, I'm going to take that strategy, 88 million. I know that million is times 10 to the sixth power. So I'm going to come over here and write 88 times 10 to the sixth. Now this is in a form that resembles scientific notation, but this is not standard scientific notation. The problem that it has is that my number here is not between 1 and 10. So I'm going to have to make an adjustment. My number between 1 and 10 is 8.8. There's times 10. And now we need to know what is the value of the exponent. So right now, my decimal point is right here, and I'm going to move it to the left 1. When we move the decimal to the left, the exponent becomes more positive. So we're at 6 here, here we're at 7. So we have 8.8 times 10 to the 7th power. 847. My number between 1 and 10 is 8.47 times 10, and we're moving the decimal point left 2. So we have an exponent of positive 2. Here we have 920 times 10 to the negative 7th power. So let's go ahead and write our number between 1 and 10 times 10. So we have 9.2 times 10. Now we just need to know the decimal. So the decimal point is here right now. And remember what I just mentioned a minute ago. When we move the decimal to the left, the exponent becomes more positive. So we're here at negative 7. This is negative 6. This is negative 5. 9.2 times 10 to the negative 5th power. Here we have 2,500 times 10 to the 7th power. So my number between 1 and 10 is 2.5. Now we need the value of the exponent. The decimal is here, and we're at 10 to the 7th power. Moving it to the left makes it more positive, so we're at 7, 8, 9, 10. 2.5 times 10 to the 10th power. And our last one, 6.7, is my number between 1 and 10, times 10, and now we have to figure out the exponent. So we're going to move it to the right, which means that our exponent is getting more negative. So here we're at negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So we are at 6.7 times 10 to the negative 8th power. Example 2, we are going from scientific to standard notation. So we have 1.50 times 10 to the 4th power. And so what I do is I start with the biggest number, and then once I start writing down numbers, I'm counting 1, 2, and so on. And we're going to put 4 things behind this 1. So 1.50 times 10 to the 4th power. So I have, there's 1 place, 2 places, 3 places, 4 places. What I did was move the decimal to the right, 1, 2, 3, 4 places, and this is 15,000. 2.53 times 10 to the 6th power. I'm going to do the same thing, my first number. So then I'm going to count them off. 1, 2, 3, 4, 5, 6. And what I come up with is 2,530,000. This next one, 6.7 times 10 to the minus 3. So this one's going to be a little bit different. We're moving the decimal place back this direction. So what I do here is I put my 0 point, and so I say 1, 2, and then my third place is the first number, 3. And then I finish whatever's left. 5.1 times 10 to the 5th power. First number, 1, 2, 3, 4, 5. We have 510,000. 7.23 times 10 to the minus 1st. So I start with my 0 and my decimal. And this is my first one. We're only moving the decimal over by 1. So we end up with 0.723. Last one, 9.24 times 10 to the ninth power. Here's my 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We move the decimal to the right 9 places, and we come up with 9,240,000,000.